Good evening. So let us take this first problem of IOQM 2022. Three parallel lines L1, L2, L3 are drawn on a plane such that the perpendicular distance between L1 and L2 is 3. So let me take this first line as L1 and then another line L2, assuming some distance to between them is 3. And the perpendicular distance between L2 and L3 is also 3. So I take an approximate equidistant line L3 also. Let me mark three of them, L1, L2 and L3. The statement further says that there is a square ABCD constructed such that A lies on L1. So let me take a proper square. So I take a square ABCD such that A lies on L1, B lies on L3. So this should be ideally something like this. I can take this use of this drawing tool so that it becomes a perfect diagram, although diagram is representative. So while working with the problem in the exam, you are not supposed to use anything, you are just using a representative diagram. But geometry is all about observing what has happened. So this basically comes with a smart observation. So let us take something like this. A lies on L1, B lies on L3, C lies on L2, and D is somewhere outside. We have to find the area of this square. So as an add-on, instead of going with trigonometry or anything like that, what I try in my capacity is simply draw a fourth line parallel to L1, L2, L3 passing through D. Now, if you look at this entire diagram, you will realize that if I join A with C, the kind of arrangement that a right triangle ABC follows with the first three lines is the same that is being followed by triangle ACD in the top three lines. So that means the distance between these two, if it is 3 and 3, so by symmetry, the distance between the top line, let this line be L4, and L1 is also essentially 3. So the question can be solved without putting much of effort now. Let me assume there is a vertical line, of course, of length 9 passing through A, and another vertical line again of length 9 passing through C, both of them there. So I have this whole length 9 and this whole length 9, and I can very well assume that this right triangle, and the third one and the fourth one are congruent by the simple fact that this angle is 90. So if this is theta, this is 90 minus theta, and if this length is 6, this length is 3. So by the same logic, this length is basically 3 and this length is 6. If I were to make it more clear, if I take this angle is theta, this is 90 minus theta, so this is again theta, this is 90 minus theta, but this length being 3 and this length being 3, so I realize that these two are congruent. Similarly, these two are congruent, but this total length is 6. So we realize that we have a square of dimension 9, which gives me an area 81. If I subtract the area of these four triangles, which is 4 times half into 3 into 6, I get my final area, which is nothing but 45 as the final answer. So we don't involve any sine theta, cos theta and trigonometry in this, and still get the answer directly. Thank you.